Welcome to General Structures 2 and Lateral Forces, lesson number 1, quiz, question number 7. And it says that we should select the correct statement, and it gives us once again A, B, C, D. And I will attempt to find the right answer and explain the wrong answers and why they are wrong. So it says select the correct statement. A, doubling the floor spans in an office building increases the cost of construction about 25%. It says doubling the floor spans. And what I would do is go back and read and see what it says. Doubling the floor span. So if you, let's say you have a 10-foot span originally, doubling that to make it a 20-foot span, 10 foot, 10 foot, and then you take out that middle support and it's 20 foot. Would it make it 25% greater? Let's go back and look in the page 16. It says structural costs also vary with a building's height and spans. For example, if an office building has a 50-foot floor span, its structural cost is roughly 25% greater than if its floor spans are 25 feet. So that's saying if you double the span, the cost is only 25% greater, which is pretty much just what this question is asking. It says doubling the floor spans in an office building increases the cost of construction about 25%. And the one difference would be 25% from construction as compared to 25% of the total cost. And if you go read through, I haven't done it myself, but read through page number 16, it looks like what they're doing is they're justifying what the total cost of the structure is compared to the total cost of the building. And it looks like this is saying total cost of construction, so I would take that as saying the total cost as compared to the structural cost. And it's saying that the total cost will be 25%. I would say no. That it's not the total cost, it's the cost of the structural, your structural materials, your concrete, your wood, your steel beams, whatever, or whatever type of materials you have. So more of the structural costs. So, but that's close. So if we don't find a better answer, I'll go with A. But let's look. I think there's going to be a better answer. Let's go ahead and look. Tall buildings have unit structural costs about 10% greater than short buildings because of the need for heavier columns. And let's go take a look back on page 16. And I'm never a big fan of these statements. Tall buildings have unit structural costs about 10% greater than short buildings. Well, what's a short building? What's a tall building? I mean, you could say a short building is commercial structure, and a tall building being the Empire State Building, and yeah, obviously that's going to be a little bit more than 10% greater than the short building. So right off the bat, I think this whole sentence is garbage. If it's right, then I will be up in arms. So I'm going to go ahead and cross it out. But let's go look back on page 16 and see what they say as a basic rule, I guess, which I never like to follow. All right, 16. I'm kind of skimming here, and it looks like on the right side, the second paragraph from the bottom on page 16, it says that tall buildings therefore require roughly 25 to 35 pounds of steel per square foot. And I think that might be a little misleading as well. What is tall, and how tall are you talking about? If you get really large buildings, it could be more. Anyways, it says resulting in structural costs that might be double for those of lower buildings. I think, and that's where they're getting that question from. It says maybe double, and it may be less, it may be more. You never know, and it comes up to every single different building what you have, but obviously they're saying maybe double. So I would say that this is wrong based on what they say on page 16. And you can justify that to yourself. I do not like most of these questions, but that's all right. We'll answer them the best we can. C, the most expensive part of cast-in-place concrete construction is reinforcing steel, and I know that is incorrect. And I believe, no, it depends what you're going to break it down to, but they might be going towards the most expensive part would be the forming it up. Now let's read what they say, because what your big issue with the concrete is the forming part. You have your forming costs being the whatever you're going to form it with, the materials, and then you have the labor. It's pretty labor intensive to form concrete, and that's where a majority of your cost is going to come from. But I just want to go ahead and Looks like it's on page 16 again, and verify that. It says the cost of cast-in-place concrete construction is made up of 3 elements: formwork, which often represents over 50% of the total. So what I assumed was correct, followed by reinforcing steel and concrete. Therefore, the key to economy is concrete construction is simplicity and maximum reuse of forms. So a lot of times when you're designing a concrete building, you want to keep in mind that, hey, these people need to reuse their forms, so you don't want to, obviously this is not going to be the perfect design example, but you don't want to make a building, I'm not going to say you don't want to make a building, I'm talking to a bunch of architects most likely, and you guys want to do what you want to do, but realize if you're going for economy, you do not want to have some sort of stepped type thing where you'll have something that's this high, and then obviously this is not a real example, and then something that's half as high, and then something that's 1.5 times as high. I hope you get what I'm trying to convey here, is that the more you can reuse these forms, especially if they have to go out there and buy specialty forms, the better it's going to be for everybody. So that's definitely a negative. All right, going back. Once again, C is no, because it says the most expensive part of cast-in-place concrete construction is reinforcing steel. And in the most part, reinforcing steel is pretty darn cheap. So just remember that over 50% or close to 50%, sometimes more, sometimes less, will be the forming aspects of it. Reinforced concrete. All right, so we're assuming it's D, but let's go ahead and make sure that we have the right answer. It says, for conventional office buildings, the structural cost is roughly 25% of total construction costs. And that sounds about right to me. Now, if it was 30, I would not be happy, because I think that's it's a difficult question. But I'm scanning the page, and I already found it. So it's on page 16. It says, structural costs also vary with a building's height and spans. For example, in an office building has 50-foot floor plans, its structural cost is roughly 25% greater than if its floor plans are 25 foot. Maybe I didn't see that right. Let's skim some more. Sorry, I just started reading. It says for conventional office buildings, the structural cost may represent roughly 25 to 30% of total construction costs. Okay, so that's good. We're good with D. That is correct answer. And I think the things that you want to take away from this is in reinforced concrete, the most expensive parts might be forming. So if you can get away with making forming as easy as possible, and there are different ways. I know in bridge type applications what you'll do, and let me get rid of some of this. So of course, if you don't want to listen to my further wisdom, if you want to call it that, you can go ahead and turn this off. But let's say you have a bridge, which I'm familiar with. Yeah, but this looks like an NU girder, let's call it, because it's Nebraska. Nebraska's the one who came up with it, I believe. So there's your NU girder. I hope that makes sense. That's rounded, so it's not really definite like that. And you'll have another girder over here. And they have these things, and you've seen them in buildings where they have precast panels, and you could have, some people will call it's like a stay-in-place form. But when you have precast concrete, typically what they'll do on a bridge is they'll have a little bit of, let me change colors, a little bit of joint filler right here, about however you need per camber. You have a little bit of joint filler right here, or whatever you need to put right here. And then on top of that, you'll put this precast panel, and they'll come in these precast concrete panels that are typically 3 inches high, and they'll come and they'll put those on top. And as opposed to having to set the forms up down low and dealing with all that stuff to make it flush with the top of that girder, they just put they'll put the joint filler type material, and then they'll put this precast panel right on top, and then they'll go ahead and pour your slab. You'll have one over here as well, and then they'll come on top and they'll pour the slab. And usually in Missouri it's 8.5 inches typically, and you'll find that it's kind of a typical slab thickness. But that is also included in your 8.5 inches. So this is 8.5, and you'll have 5 inches of slab on top of that, and then whatever you need over there. And then another, there's other different types of systems you can have. Obviously, these aren't the only ones. And maybe you have, let's say you have a steel beam, and you have another steel beam. And instead of having to come down here and form up some wood, take some wood forms, you're going to have to support that with some sort of contraption. Maybe you decide to block it up. Obviously, I'm coming up with stuff that I would never do. So this is wood. This is wood, or maybe you just have one piece that comes across here, and you block it up so it. And after you do all this, you have to come in and pour your concrete, and you'll have these. These are studs, and you'll pour your concrete on top, and you're good to go. But then you have to take all these forms out, and if you had to cut them, then you now have uneven pieces of wood. You have issues to deal with. So what they'll end up doing is, let me rewind real quick, is what I've used a lot of times is they'll use these like stay in phrase corrugated form type of systems. We'll come in here with a corrugated, and it would be better if it's the opposite way, but a lot of the times I see it this way, just to let you know, where you might tack weld it on this side, tack weld on that side, and you do it again over here, and all of a sudden you just pour it right on top of that, and you're good to go. Obviously, well, no, maybe not obviously, but what I said, how it would be better if it were the opposite way. You had the corrugations running this way. I hope that makes sense what I'm trying to convey. And they run in and out of the screen. That'll be better because you have your eye is right there working it with your bending. Your bending is going to look like this. So it's better to have that. If your bending's like this is just going to elongate and look like, ooh, and it's going to droop with you. Those corrugations aren't helping you when you're going this way. All right. I hope my extra bit of information was helpful, to say the least, and if not, then just forget it and move on. All right, I'll see you on question number 8.